So hi everyone. Today we're talking about how to solve different NLP problems, be it summarization, NER, text tagging, classification, few shot learning, word segmentation, anything using Langchains and LLMs. So let's get started. So first of all, we will be pip installing a few packages: OpenAI, TikToken, ChromaDB, Langchain, as you can see here, and then we'll be first of all starting with summarization. Okay. So in case of summarization, before starting, we need to first of all set up our OpenAI API key as an environment variable. As you can see, I am doing this here. Once you are done, in case of summarization, we'll be doing it using LangChain chains concept. I think chains I've already explained in a previous video. You can refer to that. So here we'll be using the load summarize chain. So using a web-based loader, so what we are doing, we are trying to summarize in a URL, web URL. So in that case, I have taken one of my blogs only. So I've taken that URL using web-based loader, document loaders, eventually, and then using the load summarize chain, in which I'm giving the LM object, passing the LM object documents equals to loaders.load. So basically, if you followed my RAG video, you would be understanding it, how internally it would be working. So what you need to do, nothing. You just need to mention your URL in the web-based loader. If it is a text file, you can use a text-based loader. If it is CSV file, you can use a CSV-based loader. Whatever format you have, you can have that document loader. That you need to check, and then create a chain object using load summarize chain. And then once you have loaded these documents using the loader object, you need to chain dot run docs. That's it. So the loader object will be getting all the text, and then you need to run this chain. So in this case, you can see that a good summary has been generated in terms of points. What this article discusses about. It is based on recommendation and all that stuff. So this is how you can do summarization using LangChain with just a few lines of code. Now, next, moving to tagging. So, in case of tagging, we will be discussing multiple things, not just general tagging. We'll be dividing about how you can. We will be discussing about how you can build classification models also very easily with zero shot capabilities. That is, you won't be providing any examples. So, in case of tagging, what we are doing is we are trying to generate different tags, any random custom tags for the text that we are inputting. So, here you can see that the first one is complexity I've mentioned. So, complexity is basically I'm giving a description also. So, properties will have different tags you wish to generate. So, here it is complexity, as you can see, describes how complex is a text. A higher score means more complex statement. Enum is 1 2 3 4 5 because I want to have a value with this list only. It is a predefined list. I don't want my output to be anything. Like in case of others, here you can see that I'm providing an enum. Here also past, present, future. I'm trying to detect the tense, the mood, the sentiment. Now here you can see that this is a classification problem. So if you wish to go for a sentiment classification, you can use this particular chain, that is create tagging chain, where I'm providing the type string. Description is describe the sentiment of the sentence, and enum is positive, negative. So only these two can come out. Now once you mention these properties in the required class, eventually for every sentence you would be getting all these properties. So if you see for an example, the rest of the code remains the same. I think creating this dictionary is the only tricky part, where you need to mention all the tags you wish to generate and whatever information you can provide, the type, the values you wish to have, and the description. And using this tagging only, you can create classification models also. That's the best part. So for the input, hey, I assume I saw you yesterday. You look gullible. You can see that I'm getting complexity, tense, mood, say, sentiment, everything I'm getting. Similar for the next sentence, he was so meticulous, but now he is on a decline. So you can see that the complexity has increased because I've used the word meticulous. Now, moving on to the next part, here we will be trying to do NER. So in case of named entity recognition, we will be using a slightly different chain called as create extraction chain. Right. So all the code remains almost the same. Just the chain is changing. So we are doing the same thing. Properties as we did for tagging part. Name, type is string, time, string, day. So I'm trying to extract the name, time, and day from the input that I'm giving. Rest of the things remain the same as it was in the tagging chain. We're creating an LM object and then creating a create extraction chain and then giving it an input. So here you can see that name, time, and day has been extracted from the sentence. Now, if you wish to have some model for your classification, you wish to generate embeddings also. So in this case, also we can use LangChain to generate embeddings and not any final solution. So this is the most easiest part. You can need to import OpenAI embeddings, and then you need to just call this objects embed underscore document. So you need to provide a list of documents you wish to generate an embedding for, and eventually you can see that the embedding has been generated. You can play around with the embedding size. So right now the default one is 1536. So the embedding generated for each of the sentences of the size 1536. This is how you can generate embeddings also. Now, coming to the most important part, assume that you have a label data with you, and eventually you wish to build a classification model using few shot learning, or you have ample data as well. So, previous case, in case of tagging, you saw that how you build a zero shot classification model where you are mentioning the sentiment, the description, and the enum. Like basically, these are the classes I wish to see. In case of when you have data set also ready with you, this becomes very easy. So we will be using the few short prompt template for building a classification when you have data also, text classification problem. So here you can see that in case of few short, we need to maintain a format, whatever format you wish to maintain. So here I'm maintaining a format. I'm calling the input as input. Football is a fun game, and the label is sports. Input as Sark is the best actor. Output is cinema. Input AI startups are at a boom right now. Output is tech. So basically, it is trying to extract the domain from which that particular sentence belongs. So I write this. I've given six sentences. So here you can see that for all the six sentences, I'm following a particular format. Now in the prompt template, as you can see, I'm mentioning the input variables. Input is input and output, and the template that I'm following, that is the most important part. So here you can see that input colon, the input variable becomes the input sentence. New line, even I am following a new line also, that has to be mentioned. Output colon the output variable, and then feed it to the few short prompt template. That's it. So here you can see that examples I have mentioned as this particular list of dictionaries. I have passed it. Example prompt I have passed this using this prompt template. Suffix input variable is input. Eventually, rest of things remain the same. We are creating an LLM chain now that I've already explained in my previous videos, I guess. And then we can run this chain. Chain.run India lost the Cricket World Cup final, where the final output comes as sports as correct. Because now it is able to understand that we are trying to build a domain classifier. Like given the sentence, we want to have a domain. So you can see that how using a few examples only, if you have ample examples, you can build a very strong classification model, and even multi-classification models also. Now we are remaining with multiple things. Still, Langchain doesn't support word segment. Like we doesn't have chains for or agents for segmentation or POS tagging. So in that case, we can have a custom prompt only for implementing all these things. So you can even have NER text tagging using this particular prompt. So here you can see what prompt I'm using. I'm using a URI NLP machine act as a problem machine and give output for the input. This is a text. So this particular code I've already explained in a previous video, LangChain for beginners. I will speak it again. So basically, this particular message goes into the system message. So now the LLM will behave according to the input that I've given. You are an NLP machine. Then human template is text, basically the input that I would be giving. And combining system and human template, I'm creating a chat prompt. That's it. I have already explained in my previous videos. You can refer that. Now here you can see that the first example that I'm going is creating a POS tagging machine. So as you can see that there are two variables, problem and text. So I'm passing problems as POS tag, text is the input. Now you can see that in the output I'm getting POS tags. In the second case, building a segmentation machine. So as I already told the LLM that it is a NLP Pro and it has to act like this particular machine. Problem is segmentation, text is he is not a good boss. Here you can see that the segmentation output is also there. Third one is the most a little difficult, that is dependency parsing. So it's a complex concept that is also it is able to crack. So this is how you can see that in how you can use LLMs for different types of NLP problems, be it segmentation, be it POS tagging, be it NER, be it generating embeddings, whatever, using lang chains with a very small code snippets. I hope you try this out.